Students, in this crucial situation which we are passing through, we are trying to make you safe, and we are taking classes from home to make you safe. And so please take care of yourself, stay safe, stay at home, and try to maintain the rules provided by the health authorities. And I am your subject teacher. My name is Numan Muttaki. I am a lecturer of Department of Physics from Milestone College. So now I must welcome you to my today's class. Students, from the chapter of effect of matter and pressure, we are going to solve some creative questions, some board creative questions. Here is the first creative question from Dhaka Board 2017. I have already written the STEM. Please read out the STEM. The STEM is weight of an object of area 20 centimeter square and height 10 centimeter in air and water is 9.8 Newton and 7.8 Newton respectively. And the first question, which is knowledge based question, is state Archimedes law. Question number 2 is write down the conditions of fluctuation and immersion of a body. So what will be the answer of the first question? State Archimedes law. So students, as we know, when we immerse an object in liquid or in gas, it will lose some of its weight, and the weight or lost weight is just equal to the displaced water or displaced liquid or displaced gas. So this is the Archimedes law. That means when an object is fully immersed on liquid or gas, it will lose some of its weight, and the amount of lost weight is just equal to the displaced water or displaced liquid or displaced gas. So what will be the answer of the second one? The question is write down the conditions of fluctuation and immersion of a body. So as we know, if there is a jar of water, and there is an object just inside it. This is the object inside the water. So we know there acts two forces. One is weight of the body, which acts just vertically downwards, which is W1, and there acts another force which is called the buoyancy, just like upward vertically, which is called the W2. So the weight of the object is denoted by W1 and the buoyancy is denoted by W2. First of all, we must know what is buoyancy, or what is the amount of buoyancy. When the object immersed into the water, it has lost some of its weights. Why? Because it has displaced some water from this place, and the weight of the water is just equal to the value of the buoyancy. So if it happened that in case of number 1, if W1, which is the weight of the object, is greater than W2, if the weight of the object is more than the buoyancy, then the object must sink. So it will sink when its weight is greater than the buoyancy. In this case, the density of the object is more than the density of the liquid or density of the water. In the second case, if W1 is equal to W2, that means if the density of the object is just equal to the density of the water, then it will float. It will float, but being fully immersed. It will float being fully immersed when W1 is equal to W2. That means when the weight of the object is just equal to the buoyancy. So what will happen if W1 is less than W2? That means if the weight of the object is less than the amount of buoyancy, if the buoyancy is greater than the weight of the object, then the object will float. The object will float, but being partially immersed. Object will float being partially immersed. if W1 is equal to W2, it will float but being fully immersed. If W1 is greater than less than W2, that means if buoyancy is greater than the weight, then it will float but partially immersed. So here is the conditions of flotation and the immersion of a body. This problem, the stem is the weight of an object which area is 20 centimeters square. This is the area of the object and height is 10 centimeter. That means the object has an area of 20 centimeters square and its height is 10 centimeter. In air and water, in air medium and water medium, it has a weight of 9.8 Newton and 7.8 Newton respectively. That means it has a weight of 9.8 Newton in air and it has a weight of 7.8 Newton in water respectively. So what is the first question? This question is for 3 marks. Calculate the density. That means the symbol of density is rho. We have to calculate rho, the density of the material of the object. So the answer will be like, we know rho is equal to m divided by v. This is the formula by which we can solve the density, or we can calculate the density of the material. Rho is equal to m divided by v. But before solving this, we must know the value of m and the value of v. So we can write like this. Here, what is m? M means the mass. Is there any mass? No, there is no any mass. We can write here m a double s, mass m equal to, the equation of mass is equal to W divided by G. We know W is equal to mg, and from this equation we can write like this, m is equal to W divided by G. So students, what is W? W means the weight, but here is a very confusing situation. We have already 2 weights, which is 9.8 and 7.8 Newton. But the actual weight is 9.8 because this is the weight when the object was in air. So this is the accurate weight. We can write like this, 9.8 divided by 9.8. Why? Because the ideal value of acceleration due to gravity is also 9.8. So we can write 1 kg. So we have already found the mass, which is 1 kg. Now we will go with the volume. So what is the volume? Volume. But here we have got the area. Area of about, area is equal to like 20 centimeters square. 20 centimeters square, but we have to convert this to meter. When we will go to convert this, we can write 0.002 meters square. This is the area when we have converted this to meter. So there is another hint, which is length or height, which is h is equal to, and we can denote this area by A. So we can write area A is equal to this, and height h is equal to 10 centimeter. 10 centimeter means 0.1. That is the value of height and area. The area is 0.002 meter square and the height is of 0.1 meter. So what will be the volume? So we can write volume V is equal to, what is the value of area? Area multiplied by height is equal to, area means 0.002 multiplied by 0.1 meter cube. This meter cube is the unit of volume, so we can write 0.0002 meter cube. Now we can put this value. M means 1 kg and volume means 0.0002, and the answer will be like 5,000 kg meter inverse 3. So the density will be like 5,000 kg meter inverse 3. This is the answer of this question. Now we will go with the second one, and the question is, does the stem follow Archimedes' law? Does the stem follow Archimedes' law? Give mathematical explanation. So if we want to go with this question, we must remember this, or give in our mind that the value of weight in air is 9.8 and the value of weight in water is 7.8 Newton. So before starting this question, we can write like this. There is a procedure. You can write like this. If the object is immersed into water, it will displace some water of its volume. That means when we immerse the object into the water, the object will remove or displace some water of its volume. So the volume of displaced water will be like V is equal to the volume V is equal to 0.0002 meter cube. So this is the volume of the object, and the object is immersed into the water. So the volume of the water will be like 0.0002 meter cube. So what will be the mass of the water? Now mass of the water, that means displaced water, mass M is equal to M is equal to what? Mass means W divided by G, or mass M is equal to rho G. We can write M to rho V. As we know, rho is equal to mv, so we can write M is equal to rho V. So what is rho? Rho means 1000. Why 1000? Because we know the density of water is 1000 kg meter inverse 3 multiplied by 0.0002 is equal to 0.2 kg. This is the mass of the displaced water. Now we will calculate weight of the water. Weight of the water, which is W or W prime, you can write the weight W is equal to mg. So what is M? M means 0.2, G means 9.8, and the answer will be like 1.96 Newton. So students, this is the weight of the displaced water, which is 1.96. This is the weight of the displaced water. So we can write a line like as this is the weight of the displaced water. So we can write, now the weight of the object in water, W is equal to, so what will be the weight of the object in water? you can't, you don't need to write any symbol. You can write like this: 9.8 minus 1.96 Newton. What is 9.8 or why 9.8? Because when the object was in the air, it has a weight of 9.8 Newton, but it has displaced some water. When it is in the water, the weight of the displaced water is 1.96 Newton. So the apparent weight will be like 7.8 Newton. This is just exact weight which has mentioned in the stem. So it will follow the Archimedes law. Students, this is our second creative question, which is from Slate Board 2017. So here is the stem. In this stem, after discussion of the question number A and B, we will discuss about the stem and question number C and D. So first of all, we are going to read out the question number A, which is knowledge-based question. What is called potential energy? What is called potential energy? We are discussing on chapter number 5, but this is not from the chapter number 5. This is from the work, power and energy. But what is called potential energy? Potential energy, the work done of any object when its position is changed. The work done or ability of doing work when its position or configuration is changed to another position or configuration is called the potential energy. So the next question, what is Torricelli's vacuum? Torricelli's vacuum. This is from chapter number 5. So to answer this question, we must consider Torricelli's experiment. This is a jar and this is the tube. This is the tube. In this jar and tube, there are some mercury. This is the mercury. And this is the mercury level. So, in this tube, the blank space just above the mercury level, in this tube, the blank space just above the mercury level is called the Torricelli's vacuum. This is considered as like the Torricelli's vacuum, but this space is totally blank. So, what is Torricelli's vacuum? To answer this question, we can write the blank space just above the mercury level, just above the mercury level in the tube is called the Torricelli's vacuum. As you can see, there is a hydraulic press, which is also called the Brammer press, and there are two pistons. This is piston number 1 and this is piston number 2. The radius of first piston is 4 centimeter and the radius of the second piston is 400 centimeter. There is another object which is a spherical shape object or oval shape object made of metal or something else, which has a radius of 2 centimeter and its mass is 20 gram as per our stem. So the liquid has a density of 800 kg meter inverse 3. We know this, which has 800 kg meter inverse 3 density. This is obviously kerosene. And the first question for 3 marks is find out the force on piston 1. Find out the force on piston 1. Actually, the question will be like find out the force on piston 2. This is piston 2. This indicates piston 2 and this is piston 1. So, what will be the procedure? First of all, we have to write for C, we know and the equation is F1 divided by F2 is equal to A1 divided by A2. By this equation, we can solve this problem. We have to determine F2. So, here we have some informations. Here, what is the value of A1, A2 or the F1? We have to write this. So, force F1 is equal to 2 Newton. Here is the indication. F1 is equal to 2 Newton. And radius R1 is equal to, this is R1, which is 4 centimeter. There is no need to convert this to meter. And another radius R2 is equal to 400 centimeter. This is the radius of the second piston, which is 400 centimeter. Now we can go with this equation. F1 by F2 is equal to A1 by A2. We can write F2 by F1 is equal to A2 by A1. After this, we will go with this line. We can write this line here like F2 by F1 equal to A2 by A1. Implies that F2 is equal to, why F2? Because we have to calculate the force on piston 2. That means F2 equal to F1 multiplied by A2 divided by A1. So what is F1? F1 means 2 Newton. 2 multiplied by, what is A? A means the area. The area is like a circular something, or a circle like something. So we can write the area of the circle is pi R2 square. A1 means pi R2. There is no space, so I am going with the next line. F1 means the 2 Newton multiplied by A2 means pi R2. This 2 is for this 2 square. Pi R square is the formula of the area of this circle. And A1 means pi R1 square. So we can write like this, is equal to what? Is equal to, we can write 2 multiplied by, what is R2? R2 means this one, which is 400 centimeter square, and R1 means 4 centimeter square. And from this equation we can write 2 into 10 to the power 4. The unit of force is Newton. So this is the answer of question number C, which is of 3 marks. And the question was, find out the force on piston 2. And this is the force F2. F2 is the force on piston 2. Now we can go with the another question, which is question number 4, or question number D. So what is the question? The question is, if object A is released into the liquid of stem, if object A, which is oval shape object, is released into the water, into the liquid means the kerosene of the stem, will float or immerse? Will the object be immersed or floated? So before starting the question, we can write like this. Here the density means density of the kerosene, density of liquid, density of liquid rho is equal to 800 kg meter inverse 3. And what about A? A is the spherical shape object. Radius of A, R is equal to, radius of AR is equal to 2 centimeter. We have to convert this to meter. So we can write 2 into 10 to the power minus 2 meter. To convert the centimeter to meter, we have to divide this by 100. Multiplied by 10 to the power minus 2 means divide this by 100. And the next line is mass. Mass of A, which is M, the symbol of mass is M, 20 gram. We must convert this to SI unit, that means kilogram. Then we can write 20 into 10 to the power minus 3 kilogram. This is the mass of the object. So, what will be the volume? Volume of A. So, we know as this is the oval shape or spherical shape something, the formula of volume will be like 4 by 3 pi r cube. This r means the radius of the oval shape object, which is 2 centimeter. 2 centimeter means 2 into 10 to the power minus 2. So we can write 4 by 3 multiplied by 3.14. 3.14 is the value of pi, and r. R means 2 into 10 to the power minus 2. So what will be the answer? The answer will be like 33.5 into 10 to the power minus 6 meter cube. Meter cube means the unit of volume. So we have already calculated the radius, the density. We have already written the density and calculate the volume, which is 33.5 into 10 to the power minus 6 meter. So what will be the force? Actually, what will be the weight? Now we should calculate the weight of this object in air. After calculating the volume, we must calculate the weight of this object in air. So we can write like this. The weight of A, the weight of A in air. Weight, what is the symbol of weight? W is equal to mg. So what is m and what is g? M is the mass, which is 20 gram, means 20 into 10 to the power minus 3 into 9.8. 9.8 is the standard value of acceleration due to gravity, and the answer will be like 0.196 Newton. This is the weight. This is the weight of the object in air. This is the weight of the object in air. Now, the question is, will it be fluid or immersed? So we can write the line like, if the object is released into the liquid, if the object is released into the liquid, then it will displace some liquid of its volume. That means if the object is released into the water, it will remove or it will displace some liquid, or it will displace some kerosene from this place, which volume is just the volume of this object. So we can write after this line, we can write the volume of displaced liquid V is equal to, will it be V or V prime? We have already used V for the volume of this object. V prime is equal to, just equal to the volume of this object, which was 33.5. 33.5 into 10 to the power minus 6 meter cube. So this is the volume of the displaced water. So what will be the weight of the water? Now the weight of displaced water displaced liquid, not water, the weight of the displaced liquid, W is equal to mg. W is equal to mg. As we have already used W for the weight of the object, we can write W prime is equal to mg. So what is m? M is the mass of the liquid. We don't know the value of the mass of the liquid, so we can write m is equal to rho v. M is equal to rho v. Why? Because we know there is an equation for rho. Rho is equal to m divided by v. So from this equation we can write m is equal to rho v. So here is the equation, m into rho v. Rho v. V means this v. So v prime multiplied by g equal to, rho means 800. 800 is the density of the kerosene. V prime means 33.5 into 10 to the power minus 6, and G means 9.8, and the answer will be like 0.263 Newton. This is the weight of the liquid, or this is the weight of the displaced liquid. So students, the main point is the weight of the object or weight of A was like 0.196 Newton, and the weight of the displaced water is 0.263 Newton. This was the weight of the object, which was W, and this is the weight of the released or removed liquid, which is 0.693. So from these two values we can write as W prime is greater than W. What is W prime? W prime means the weight of the displaced water, and W means the weight of the object in air. So as W prime is W, then the object A will float. The object A will float. But if it happened that the weight of the object is more than the weight of the displaced water, then it must be immersed. But in this case, the object will be float. Being, you must write this line, B-E-I-N-G, being partially immersed. So this is the answer of the question number D. Thank you very much. So students, thank you very much for being with me. I think you all understood the mathematical problems, and after this lecture we will provide some homeworks and hope you will submit in your respective groups, and take care of yourself and be safe. Thank you very much.